Qubit, I've stared at this galaxy for an hour, and I can't see anything holding it together.
Ah, you're looking for the skeleton I promised you.
The invisible thing, the one that pulls.
Dark matter. Invisible because it gives off no light at all, not one glimmer.
Then how do you find something invisible?
The same way you find the wind, little explorer. You watch what it moves.
Okay, so what does dark matter move?
Everything. And today, we'll catch it moving an entire galaxy.
Then let's go catch it. Vega and Qubit, and the galaxy that should fly apart.
That beauty ahead of us is spinning so fast it truly should fly apart. To see why, we need a quick lesson from home, our own solar system. The sun's gravity is a grip. The closer you orbit, the harder it holds you. Close planets must race to keep from falling in. Mercury tears along at 47 kilometers a second.
Every second?
While faraway Pluto, where the grip is feeble, just ambles along, about 10 times slower. That rule comes straight from gravity. It works for anything orbiting anything. Now scale it up. A galaxy is 100 billion suns, all orbiting the bright, crowded middle.
So stars near the middle should race, and stars at the edge should crawl.
Precisely what gravity predicts. The edge should be the slow lane. So, let's clock them. Qubit.exe galactic speed trap activate.
You're about to give a galaxy a speeding ticket.
First, the middle lane, a couple of 100 kilometers a second, just as predicted.
Okay, now the edge, nice and slow, right?
Reading the starlight at the rim now. That cannot be right.
Qubit?
The edge stars are moving just as fast as the middle ones.
But the grip is weaker out there. You said slow lane.
I did, and by the gravity of everything we see, those stars are far too fast to stay. At that speed, the edge should be flung clean off into the dark.
Like losing your grip on a spinning merry-go-round.
Exactly. Spin faster than your grip can hold, and off you fly.
So why is the galaxy still a galaxy?
That is the question, and this isn't one odd galaxy. In the 1970s, astronomer Vera Rubin clocked stars just like this, starting with a galaxy you know.
Wait, Andromeda, our 2.5-million-year-old friend?
The very one. Rubin watched Andromeda's edges and found them racing, just like these. She checked another and another, dozens, everyone spinning too fast to hold together.
Every galaxy is breaking the rules?
Or every galaxy has more grip than we can see.
More grip means more gravity, and more gravity means more stuff.
Enormous amounts of it, unseen mass, hiding exactly where we see nothing at all. Picture it wrapped around the whole galaxy, a vast invisible cloud, the halo.
So the glowing part is just the middle bit?
What we see is like city lights at night, a bright sprinkle inside something far larger and dark. Its gravity is the extra grip. With its pull added, the racing edge stars are perfectly safe.
Okay, but Qubit, inventing invisible stuff to fix our maths, sounds a lot like cheating.
Spoken like a true scientist, one clue is a guess, so let's demand a second witness. Remember the smudge on our window, the galaxy that gravity bent into a ring?
Gravity-bending light. How could I forget?
Bent light is a weighing scale. The heavier the thing in front, the harder the light bends. So we can weigh a galaxy without trusting its glow, just measure the bend.
Sneaky, the light tells on the mass.
And weighed by their bending, galaxies come back heavy, 5 times more matter than the glow shows.
5 times?
2 utterly different methods, and they agree on the same invisible mass. Even our old smudge was mostly dark matter's work. The glow alone couldn't bend a full ring.
So the smudge was dark matter showing off this whole time.
And there is a third witness, older than both. In 1933, astronomer Fritz Zwicky watched a swarm of galaxies buzzing round each other far too fast. To hold together, that swarm needed far more mass than all its light added up to.
The same missing grip, 40 years before Rubin.
That clue waited 40 years. Rubin's patient star clocking finally made the world listen. And when we map where the hidden mass sits, galaxy by galaxy, a shape appears.
It looks like a spiderweb made of light.
The cosmic web, great glowing threads of galaxies strung across the universe. They didn't choose that pattern. They grew along it on a dark matter scaffold laid down first.
The skeleton, it isn't just holding galaxies, it arranged them. Hold on, maybe it's ordinary stuff we can't see, like dead stars, cold gas, or a zillion sneaky black holes.
A brilliant objection. Scientists spent decades hunting exactly those suspects. They found dim stars, cold gas, even black holes, but nowhere near 5 times what we see. And it refuses to behave like ordinary matter. This is a genuinely different kind of stuff. Ordinary matter glows when hot, blocks light when thick, and splats when it collides. Dark matter does none of it. No glow, no shadow, barely a bump even with itself.
So if I threw a snowball of it,
It would sail through the ship, through the planet behind us, and out the other side without a whisper.
wait, is any of it going through us right now?
Very likely, the galaxy is soaked in it, drifting through ships and explorers without saying hello.
That is so creepy and so cool.
Not creepy, just shy. Dark only means it never talks to light, not that it's sinister.
So what is it? What is it actually made of?
And there, little explorer, is the honest edge of the map. Nobody knows yet. Labs deep underground have waited years for one piece to tap their detectors. So far, silence.
Another mystery like the push?
A very different kind of mystery. And the difference matters. With dark energy, we know almost nothing. A name pinned to a push we can't explain. With dark matter, we know everything except its name. Where it is, how much, what it does. We've weighed it and mapped it, real charts of the invisible.
We made maps of something nobody has ever seen.
Whole atlases. We know it's there and how much. We just haven't caught a piece yet. The recipe of everything. Ordinary matter, you, me, every star and planet, about 5%. Dark matter, the pull, is about 27%, 5 times all the ordinary stuff. And dark energy, the push driving space apart, is the remaining 68.
The pull and the push, the two great invisibles.
Never mix them up. The pull builds, the push spreads, together 95% of everything.
Wait, our galaxy has one of those halos too, right?
Of course, clock our own edges, and the Milky Way comes out about 90% dark.
We live inside the skeleton.
Be glad we do. Without that pull, the universe's first gas would have scattered before gathering into galaxies. No galaxies, no stars, no stars, no planets, no explorers at the window.
So the invisible thing is part of why I exist.
Every star you've ever wished on was born in a nursery that dark matter's gravity built.
And we found it without ever seeing it, just by watching what it moves.
Like the wind in the trees, Rubin simply watched more carefully than anyone before her.
Let me climb it back. Galaxy edges spin far too fast for the stars we can see. Bent light weighs the galaxies at 5 times what their glow shows. And the cosmic web itself grew on a scaffold of its pull.
Dark matter, 27% of everything, the pull that builds. Standing right beside dark energy, 68%, the push that spreads.
Qubit, that's the invisible 95%. What about the 5 we can see?
The bright slice. You, me, the planets, and every star in the sky. Now that is a story with an answer. Next time, every atom in your body was forged inside a star.
I am made of stars?
The iron in your blood, the calcium in your bones, cooked in stars, scattered in their grand goodbyes.
If you just checked whether you're glowing, same. Subscribe so you're here to meet the stars that made you.
Setting course, running on genuine star-made parts all the way home.
See you out there, explorers.